Today we're going to have a look at how to multiply by 5. By now you'll have learnt our basic facts that most people have mastered since a long time ago. For example, 5 times 2 is 10, 5 times 3 15, 5 times 4 20, 5 times 5 is 25. We can learn these facts really well, and one of the best ways to do that is skip counting. 5, 10, 15, 20, 25, 30, so on like that. And because you're in my maths class, you've probably learnt most of those already. So what else can I teach you about the 5 times table? Well, I've got a couple of tricks. I'm pretty excited. So I'm hoping that you'll really enjoy these next two little bits of information that'll help you figure out 5 times tables for any numbers. So the first one is a standard algorithm, the sort of thing that you've probably seen your mum or dad or grandparents do, and it's a very reliable way of multiplying numbers. Now it works for other times tables too, but we're going to show you this one with the 5s just so to get to the point of where we're at. So for example, if we wanted to multiply a random number, say like 23, and we want to multiply that by 5, we can put our times there, put the 5 there. And it's a strategy where you break down the problem into little chunks and solve them one at a time and add up the solutions. So pretty straightforward kind of stuff. So we start with our ones column. As you know from other times when we've talked about numbers, we talk about place value a lot. So these are the ones and these are the tens. Just quickly change color. So we're going to multiply the ones first. 5 times 3 is 15. I'll put the 5 there. And I carry the 10 from the 15 up into the tens column. Here's the trick to watch out for. Go 5 times 2 first and then add the 1. So don't add the 1 before you multiply. 5 times 2 is 10 plus 1 is 11, so I've got 11 tens, which gives me a total of 115. It's a very reliable system that works really well. We can try it with a different one. It can even work with very large numbers. Because we're breaking it down into each of those in little parts, using what they would call a part-whole strategy, none of the questions that we're faced with are too difficult, and it's just knowing how to glue them all together to get our total answer. In this case, we'd go 5 times 2 is 10, so the 0 goes there. 10 from the 10 goes up there with all the other tens. 5 times 7 is 35, plus 1, 36. 6 there, 6 tens. 3 hundreds go up in the 3 with all the other hundreds. 5 times 4 is 20, plus 3 is 23. 23 hundreds in this case. The 3 hundreds go there, and the 2 from the 23 goes up there. These are thousands, of course, now. 6 times 5 is 30, plus 2. We can just jot our 32 down there. I could put the 2 there and the 3 up there, but you get the point. 5 times 0 is going to be 0 anyway. So our total then is 32,360. Now have a look at the 0 for a second. Anything that you multiply by 5 is going to end in either a 0 or a 5. If your answer ends in another number, you may have to recalculate. You might have got your first part a little bit muddled up. So you know it's in the 5 times table if it ends in a 0 or a 5. So find yourself a bit of paper and jot down these questions. You can just pause the video here, have a go at these 3, see what you come up with. Alright, hopefully you had enough time to give that a go. I can't really tell from this end because I'm just speaking into a camera. So let's go through it step by step. 5 times 2 is 10. 1 goes up there with the other 10s. 5 times 5 is 25 plus 1, answer 260. 49 times 5. I'm going to take a guess here before I even figure it out. 49 is pretty close to 50. 5 times 5 is 25, so 5 times 50 would be 250. Take away 5. My answer should be something like 245. Bit of a guess. All right, let's see. We can call that an estimate. Okay, 5 times 9 is 45. 5 goes down there. The 40 goes up with the tens. 5 times 4 is 20. Plus 4 is 24. Huh. I think we were right. 245. Pretty good. Bigger one this time. 83 times 5. I know 8 times 5 is 40, so my answer might be 400 and something. 415 would be my guess, a bit of a guess. Let's see. 5 times 3 is 15. Carry the 10 up to the other tens. 8 times 5 is 40. Plus 1, 41. 415. Now, what you'll have noticed is that you might be starting to see a bit of a pattern. And this is what I want to get onto next. A mental strategy where you can do 5 times table in your head. I'll explain that in a second. So take a look at this one. I've deliberately chosen an even number here to demonstrate my point. These are easier than odd numbers, and I'll show you why in a second. So let's first figure it out using our old-fashioned bit of paper method. 5 times 4 is 20. The 0 goes there. 2 goes there. 5 times 8 is 40 plus 2 gives us a total of 42 tens. 420 is our answer, right? That's pretty good. Have a look though. I want to see if you can spot the relationship here. If you look closely, 42, if I circle it, is half of 84. I think we can use that. So here's the strategy. When you're presented with something like 84 times 5, you can get to a point where you do it in your head. How do you do it in your head? Well, we know that 2s and 5s and 10s are related. 2 times 5 is 10, 10 divided by 5 is 2, 10 divided by 2 is 5. That sort of thing. They're all part of the same family of facts. And we can use that happy relationship to calculate in our heads the 5 times tables for even large numbers like this. This is where it gets quite cool. So in this case, I would look at 84 and say, what's half of 84? Easy. 42. Because of half that, I need to multiply it by 10 instead of 5, because 10 is double 5, right? So now I've got this very simple calculation. 42 times 10 is 420. You'll notice that it's the same as this 420 that we came up by using this algorithm. How awesome is that? All I had to do in my head was think half of 84 is 42 times 10 to 420. Boom. Done. Correct answer. What though if the question isn't quite as easy as this? What if there is an odd number in the ones? Well, you can still do it, but you might end up using your decimals a little bit. I'll show you what I mean. It's still easy, just not quite as easy as this one. Let's go back to our original question, which was 23 times 5. Now, because you were watching this video earlier on, you know that the answer is 115. How, though, can we prove this as a point? Well, let's look at 23. If we go 23 and halve it, we get 11.5. You can double check that if you like, but you know half of 24 is 12, so half of 23 is going to be 11.5. Makes sense. Now, you've already done some multiplying by 10, so you won't find this too difficult. If we multiply that by 10, basically all we're doing is losing the decimal point, really. We're shifting them across, remember, in their place values, so that ultimately our answer becomes 115. So what happened in your head is that you've gone half of 23. Now this is a symbol that means half of, it's related to fractions and people use it in mathematics all the time. Half of 23 is 11.5. 11.5 times 10, 115. Now, I've written it down so you can see what was happening in my head, but in the end, you don't need a piece of paper. This can be happening inside your head. All right then, have a go at these two. One's an even number, which should be easy to have. One is an odd number, which will give you something 0.5. Have a go, see if you can do it in your head, and keep the answers there, and when you unpause this video, you can see if you came up with the same answers. All right, let's see how you did. Half of 48, 24 times 10, answer 240. If you got 240, you are bang on. This one, 65 times 10, half of that, well, half of 5 is 2.5, half of 60 is 30, so it's going to be 32.5 times 10, not 5. Answer, 325. How did you go? Were you close? Oh, that's good. At some point, you might find that you're not 100% comfortable with decimals. That's okay. It takes a wee while to get used to them. Thinking of parts of numbers as well as whole numbers can be a bit mind-blowing. Is there another way I can use this strategy that we just talked about to solve 5 times table questions? Now this one is awkward because the 1s and the 10s are both odd. Well, yes, there is a way you can do it. That's quite handy. Instead of halving it first and then multiplying by 10, you can do a switcheroo. I can just multiply this by 10 first to get 730, and then halve it. Divide by 2, put it over 2, however you want to do it. Now you might find that's easier. It'll still give you the right answer. You might have to do 2 steps in your head. Now you might know that half of 700 is 350. You know that half of 30 is 15. So if you add 350 and 15, you would get 365. Now, if you don't believe it, what you can do is double check. While you're learning how to do it, double check. Do we believe it? What was that question? 73 times 5, 365. Ooh, we're into a winner. It's a handy little strategy that you can do. You need to know your doubles and halves, you need to know your place value, but if you've got those things in place and you know your basic 5 times table, you can do other tricky ones in your head. How nice is that? Little side note, 365 is an interesting number. That is how many days they say are in a year. Days in a year, 365. But is that 100% true? Well, actually, in a year, there's closer to 365 and a quarter. That's why every 4 years we have a leap year, because you have a quarter year, running out of fingers, quarter year, so quarter, and you have to add a day every 4th year to make up for those quarter days that we lost when we only counted 365 days. Well, I hope you had fun learning some new strategies there, guys. Play around with the fives. Don't be shy. Make mistakes. Learn things. Have a go. See you later. Bye.